Okay, so hi everyone, Senan this side, and in this video we are going to solve this LeetCode problem, that is network delay time. So you are given a network of n nodes labeled from 1 to n. You are also given times, a list of travel times as directed edges. Times of I is ui, vi and wi, where ui is the start node or the source node, vi is the target node, and wi is the cost associated with that edge, or basically in this case the time it takes to travel from the network packets take. So it is basically the time that network packets take from UI to VI. Okay, so we will send a signal from a given node K, return the minimum time that it takes for all the nodes N to receive the signal. If it is possible for all N nodes to receive the signal, if it is impossible, then return -1. So basically this is saying that if your network is somehow disconnected, you have to return -1. Otherwise, if your graph, what you get, or the network disconnected, and you can reach every edge somehow from the start node, that is the K, then you would have a possible answer, right? So the only thing you need to know in this is you have to start from 1 to n. So the labeling is 1 based indexing. So you have to keep that in mind. And obviously the logic or the approach that I'm thinking of is to use the Dijkstra's algorithm. And through that, I would basically find the distance or the time taken by the signal to reach each and every node starting from the node K. And in the end, I would return the maximum of that list. So that is the whole idea of this video. So let's look at the code and how am I implementing this. So since I have a 1 based indexing, so I create an adjacency list of n plus 1 size, and for all the time elements of this, so basically this has the edge information. What I do is I get the u, get the v, and I get the time or the weight, and I take that into my adjacency list. Since we are using Dijkstra's algorithm, we are going to use a priority queue. So I would be taking a pair as an input. The first would contain the time taken to reach that node from the source node, and the second would be the node itself. So this priority queue is basically a min heap because we are using this function or this comparator, right? Now keep track of all the timings. I create a vector of size n plus 1 and initialize all the elements with int max. And since we have no node labeled as 0, I would mark that as int min, such that I'm not taking this node into consideration at any point of time, because in the end I would try to search for the max element, right? So if time 0 is int max, that would cause some problems, obviously, because 0 is not a node at all. So in our graph, so I initialize the source node. The timings to reach the source node is 0, and I push that into my priority queue. So this is the distance from the source node to reach this node, and this is the node that we are taking or pushing into the priority queue, which is the start node or the source node. Now we do the basic Dijkstra's algorithm, and this is we get the topmost element, we get the time it takes to reach this element. I take out the node from this, so because top is a pair of element, right? So I take out the time, I take out the node, and I remove that from my priority queue. Now what I do is I go through all the edges of this particular node, and I find all the adjacent nodes. I find there the edge weight that I had to travel to get to this node, and after that I calculate the new time. New time is what? The time taken to reach this node plus the edge weight from to reach this node to this edge adjacent node. So that is the net time that you can take to reach this node. Now if timings of adjacent node is greater than the new time, so that means I have found a new path which takes a shorter time. So what I do is I update the timings, and since I've updated it, so the remaining nodes could have something, the remaining nodes could have a shorter path because I found a shorter path for this node. So then that is the reason I push it again, because I need to consider this node again. And after that, what I do is in the given this array of elements, the only way I would have an int max in my timings array is because I was not able to reach that node. So that node was unreached. So if that case, in that case, so if my max time is int max, so I return -1 because there was a node which I was not able to visit. Otherwise, I return the max time. And since I'm doing a maximum, I'm trying to find a maximum element, so this 0 would never be a contributor because it's int min, right? So it's so negative that you won't be considering at all. Obviously edge nodes are positive, so the value of timings would always be positive. So a negative value, let's say if you initialize this to -1, then also would work. So one more thing, this, if you are not familiar with this function, you can just run a for loop, and if at any point of time you find int max, you just return -1. Otherwise you update your maximum element if you found one and just return that. Now one more doubt you could be having is, it is saying minimum time, then why are we calculating the maximum time in this timings array? So this is not that big of a doubt. The only reason I'm doing this is because after doing this Dijkstra's algorithm, I know that the timings array would store the minimum time taken from the source node to that node, right? The time to reach from source node to that node. So the maximum of this timings array is the minimum time for that element to get the right. So we need to send this in all nodes. So the bottleneck of this problem is the node that is the farthest away from the source node, right? So that is the reason we are using the maximum element, because we already found the minimum path, right? So this minimum is basically talking the minimum path of all the array in the timings array, and in the end we found which is the maximum that you had to take at any cost to reach the last node that is the furthest away from the source node, assuming we are using the shortest path. So that is the whole video about. Time and space complexity would be, this would be same as Dijkstra. You just need to have this additional overhead of creating your own adjacency list, and in the end you have a big O of n searching of max element. Again, I did I think that I did not mention this is because whatever this max element returns, it is basically a pointer, right? And so you have to dereference that pointer, get the value of that. Yep, that was the video. Hope you understood this, and yep, stay tuned and I'll see you in the next video.